Welcome back. Today let us solve some questions on permutation and combinations. So first question. A bouquet has to be formed from 18 different flowers so that it contains no less than 3 flowers. Okay, so it means it can be 3 and anything above 3 up to 18. How many ways are there of doing this in? So we have to choose, right? This is choosing. So choosing is nothing but combination. So what we have to choose? We have to choose greater than or equal to 3, correct? So any n greater than or equal to 3 up to 18 from 18 flowers. So what will be the total? So it will be 18C3 plus 18C4 and so on up till 18C18, right? So if you see, like, it is like 15 numbers, you don't have to calculate everything separately and add it, right? So we know the formula. So NC0 plus NC1 up to NCN. So this is equal to 2 power n, right? Now we have 18. So if you have 18C0 plus 18C1 up to 18C18, we'll have 2 power 18. And we don't have first 3 terms. So if you have 18C3 plus 18C4 and up to 18C18, then we can just subtract on the other side, right? Minus 18C0 minus 18C1 minus 18C2. So if you see 18C0, this is nothing but 18 factorial by 18 factorial into 0 factorial. So it cancels, it is 1. So this we already saw, any NC0 is 1. Next is 18C1. What we have? 18 factorial by 17 factorial into 1 factorial. So this and this goes by 18 and this is just 1. So we get 18. So NCN is always equal, NC1 is always equal to N. So these both we already know. Only 18C2 we need to calculate. So this is 18 factorial by 16 factorial into 2 factorial. This goes by 18 into 17. So this goes by 9. If you multiply, we get 63, 15, 153. So this is nothing but 2 power 18 minus 1 minus 18 minus 153. So now you can go to the calculator. This will simplify things and save time for you. So 2 power 18 minus 1 minus 18 minus 153. So this will give you 261972. So this will be the total number of ways of arranging the flowers. Okay, so choosing the flowers, not arranging. Bouquet is just choosing the flowers, right? It's just like combination of different types of flowers. So the answer is 271972, 261972, which is option C. Let's move on to the next question. In how many ways 5 MBA students and 6 law students can be arranged together so that no 2 MBA students are side by side? So we need to arrange, let's say MBA students I represent by M and law student by L. So we have 5 MBA students, 1, 2, 3, 4, 5 and 6 law students, 4, 5, 6. So we have to arrange them in such a way that, like, this is not a possibility, right? No 2 MBA students should sit together. So we have to arrange it in some way like this. 2, 3, 4. And there are 6 law students. So we should arrange some way like this, right? So how do we do this? So if you see, each MBA student is on the left side and right side, you should have a law student, right? So that is the catch here. So first what I will do, I will just arrange law students like this with a gap in between, 1, 2, 3, 4, 5, 6. So these are the gaps. So there are 1, 2, 3, 4, 5, 6, 7. 7 gaps are there. So what I'll do, I'll 5 MBA students are there. I'll put them among these 7 places. I'll put them in any 5 of them. So how much number of ways can I achieve that? So if you put them that way, then this is achieved, right? So no two MBA students will be together, because only if there are two gaps in between two law students, then the MBA students can sit together, right? But I have restricted it to one gap, so only one MBA student can sit in between two law students. So whatever the question constraint it state, that is satisfied. But how many ways can I do this? So there are 7 places. I need to pick 5 of them. So I have to pick, meaning choosing. Choosing is combination. So it is 7C5. Once I have chosen, right? So let's say I have chosen these places. 3, 4, 5. Now these MBA students and law students are itself different. Let's say M1, M2, M3, M4, M5. L1, L2, L3, L4, L5, L6. So I can permutate among them. So MBA students, so they sit in 5 places. If I permute that 5 places, 5p by 5, what will I get? 5 factorial. This MBA. And law student, 7 places. And if I permute 7p7, I get 7 factorial. So the total number will be 7C5, which is first I'm choosing these places where the MBA students will sit. Then I permute among them itself, which is 5 factorial. Then I permute the law students, which is 7 factorial. So this is the answer. So like we can simplify this, right? So 7 factorial by 5 factorial into 2 factorial into 5 factorial into, there are like only 6 law students, right? So this is 6 places and 6p6. Really sorry for the confusion. So this is 6. This still remains 7 because the number of gaps is 7. So when you have 6 law students, the number of gap will become 7. So this is 6 factorial. So 5 factorial cancel. You will get 7 factorial into 6 factorial by 2 factorial, which is nothing but option A. Okay, let's move on to the next question. In how many ways can A, B, C belongs to natural numbers be chosen such that A plus B plus C equal to 10? Okay, so we want A plus B plus C equal to 10. So what can we do? And A, B, C are natural numbers. So A, B, C are greater than or equal to 1. Right? So what I can do, I can put a table and I can say A equal to 1. Then I can change between B and C. So B is 1, C will become 8. Then B is 2, C 7, 3, 6, 4, 5. Right? This way I will build a long table. But this can be converted into a simple method. For example, if I have 10 marbles, let's say I have 10 marbles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 2 sticks. So I have 2 sticks. And if I say only 1, 2, 3, 4, 5, 6, 7, 8, 9, in between the marbles, only here I can place the sticks. Okay, I can either place the stick here and here. So this is one combination. Or I can place the stick here and here. So each time when I place it, right, what happens is the entire 10 marbles is divided into 3 compartments, right? So here there are 3 marbles, here 4, here 3. But if you see, the sum of all these 3 should still be equal to 10, right? So what I will do, I'll assign each of these compartment each time I get, right, to A, B and C. Okay, so then I will be able to achieve all the values of A, B and C, right? You can take 1 minute to think about it. So this what ABC belongs to natural numbers. What that constraint says is no 2 sticks can be together. So if there are 2 marbles and 2 places, if there are 2 sticks together, then it is like B is equal to 0, right? So this shouldn't happen. So we are giving 1 place for each, right? So there should be only 1 place between each marbles, such so that the minimum number between two sticks is restricted to 1. Hence, this constraint ABC belongs to natural number is satisfied. So now I'll just redraw this. I'll just remove this. Sorry. So this I can convert into. So this is 3 variables, 2 plus sign, right? And the count is 10. This I can convert into 10 marbles and placing 2 sticks among them. Again, if you see in the marble when I am taking, I did not consider this endpoints, right? Let's say there are 10 marbles here. I did not consider this endpoints. What will happen if you place the stick here? It is like A equal to 0, C equal to 0, right? So to avoid that condition also, I am not placing anything on the sides. Otherwise, in the previous problem when we see, we can still place the M here, correct? But here we shouldn't do that because we want A and C also to be greater than or equal to 1. Okay, now I will draw the 10 marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many places I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9 places, and how many sticks? 2 sticks. So I have to choose 9 places to place the 2 sticks, right? So this will be the number of combinations of A, B, C, right? So this will exhaust all possibilities. We needn't switch between this and this because we are not actually counting the sticks, right? We are only seeing how many marbles are there in the 3 groups that these 2 sticks provides. So this 9C2 will be the entire count itself. So what will this be equal to? 9 factorial by 7 factorial into 2 factorial, which is nothing but 9 into 8 by 2, 9 into 4, which is 36 ways. So this answer is 36. Okay. So you should also be able to extend this to higher numbers, right? Let's say A plus B plus C plus D plus E equal to some 52, right? How will you do for this? Here the total marbles is 52, okay? So how many gaps they will leave? So the number of gaps will be n minus 1, correct? If there are n marbles, the number of gaps will be n minus 1. Okay, so it will be 51. C. And how many sticks? 1, 2, 3, 4. Number of plus signs. So 4 sticks. So if you visualize it this way, this one you can easily arrive at. You needn't mug up this formula, right? So that is the main idea. Okay, so we'll move on to the next question. So in how many ways can A, B, C be chosen such that A plus B plus C equal to 10 and A, B, C are all non-negative? So this one is same as the previous question, but in the previous question what we had? A, B, C belongs to natural numbers. Here we what we have? A, B, C belongs to whole numbers, right? So this is nothing but all natural numbers including 0. So now 0 is also included. So how do we modify this? So do you think like putting two spaces between marble will be a right choice? So will this be a right choice? And in the ends, let's say I'll put 1. So this will not be the right choice because even though this corresponds to 0, but if you see, if I place the sticks here and the second set of 6 if I place it here, these both correspond to the same thing, right? In terms of ABC, placing the sticks here or here corresponds to same thing. So we are just counting it many times. The same possibility, we are counting it many times. So this is not possible. So what else can we do? There is a simple trick. So what I do is, so A comma B comma C should be greater than or equal to 0, right? So A is greater than or equal to 0. What I do, I add 1. So A plus 1. Then this side also I need to add 1, right? So A plus 1 is greater than or equal to 1. So I will assign some capital A to this. Capital A is equal to A plus 1. Then what I have? Capital A is greater than 1. Similarly, capital B is B plus 1 and capital C is small c plus 1. Then I will have capital A, capital B, capital C greater than or equal to 1, correct? So A, B, C are natural numbers. So if they are natural numbers, then I can easily apply the trick I found in the previous question. And if you see this to this, the mapping is 1:1, 1:1 mapping. So if I find A, B, C, then they map to exactly one ABC combination, correct? So it is just sufficient for me to see how many ABC combination of this is possible. The capital ones are possible. Then I can say it will be same as the small ones. So how do I change this equation to capital? I have A plus B plus, I'll write it down. I have A plus B plus C is equal to 10. So what I do, I add 1 on both sides. Plus 1, plus 1, plus 1. So here it will be plus 3. Now I haven't changed anything. And then I group it. So now I have A plus B plus C is equal to 13. So now what I do, I know how this ABC belongs to natural numbers. So what is the number of ways? So it is 12, because I'll have 13 marbles, but I'll have 12 gaps. And how much sticks I have to place? Out of the 12 places, I have to place 2 sticks. So this will be the total number of ways of ABC. And as I said, it will also be the same as small a, small b, small c, because of 1:1 mapping. Okay, if you understand this, like even if you have larger number of variables, and if this number is large, you will still be able to do it. So just to finish it, this answer is 12 factorial by 10 factorial into 2 factorial. I get 12 into 11. So this is 6. This is 66 ways. So there are 66 combinations. Okay. So here, if you see, so I'll just take an example. So I have 0, 0, 10. This is one possibility, right? So 0, 10, 0, 10, 0, 0. So all these three are counted in the 66. Right? Why it is so? If you convert this into the capital A, capital B, capital C, then what will you get? You will get 1, 1, 11, and then 1, 11, 1, and 11, 1, 1. So what does this mean if I have 13 marbles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the first one, 1, 1, 11 means I'm placing the sticks in this place, right? And the second one, what it means? 1, 11, 1. I'm placing the sticks here, correct? So these are different combinations, right? So it is all in third one also I have to say I'm placing it here. So these are all different combinations of what we have considered. So including these three, it is the 66 ways, not just 0, 0, 10. Since I'm saying combination, it doesn't mean I'm only taking this thing and no, this is not considered. No, not like that. So including all these three, it is still 66. Okay, 66 ways. Okay guys, so this will be very helpful in examination. You can see many repeated questions year after year asked about based on this trick alone. Okay guys, take care, bye.